Next, one more problem in Muller method. Perform two iterations of Muller method to find the root of the equation. To find the root of the equation f of x equal to cosine x minus x into e power x equal to 0. Solution. What is the equation? F of x equal to cosine x minus x into e power x. This is f of x, and in the question it is also given, use the initial approximations as x naught equal to minus 1, x1 equal to 0, x2 equal to 1. Now this is the function f of x. From this function f of x, x naught equal to minus 1 implies f of x naught nothing but f of negative 1. The simple notation is f naught. F naught stands for f of x naught. So this is cos of minus 1 minus minus 1 into e power negative 1. Take negative 1 in terms of radians. Okay, its value is 0.90818,175. Next, at x1 equal to 0.0, f of x1, that is notation f of 0 is nothing but f of 1 equal to cos 0 minus 0. This is 1. At x2 equal to 1, this is f of x2 value, nothing but f of 1. Notation is f2. F of x2 stands for f2. Its value is negative 2.1779795 These are the initial values at x0, x1, x2. The corresponding values f0, f1, f2. Now first iteration. So remember the formula, Muller method formula. In that, first I have to calculate h2, that is x2 minus x1, 1. h1, x1 minus x0, x1 minus x0. So what is this x1? x1 value 0, x0 value negative 1, so this becomes positive. Next one, lambda 2. Lambda 2 is what? h2 by h1. So this value 1. Next, delta 2 value. Delta 2 is what? 1 plus lambda 2. This value 2. Next one, what? g2. What is the formula of g2? Lambda 2 square f0 minus delta 2 square f1 plus lambda 2 plus delta 2 into f2. Substitute all these expressions and the result is minus 9.62575681. And one more, what is that? c2. c2 formula is lambda 2 into lambda 2 f0 minus delta 2 f1 plus f2, and this c2 value is minus 3.26977. Now what is the value of g2? g2 is what? Less than 0. So since g2 is equal to what? Minus 9.62575681 is negative, we consider negative sign in the denominator of Muller's formula, denominator of Muller's formula. That is, what is Muller's formula in that? Lambda k plus 1, that is lambda 3 is equal to minus 2 delta 2 f2 by g2 plus or minus. So since g2 is negative, here you take negative sign, under root of g2 square minus 4 delta 2 f2 c2. So this value is minus 8.711918808 over 15.5992628, and this result is 0.5584828. Therefore, what is our next approximate root formula? Xk plus 1 is equal to, that is already x0 is there, x1 is there, x2 is there. So next root is x3. x3 is equals to x2 plus lambda 3 into x2 minus x1. This is the formula of Muller's method. So substituting every value, the result is 0.44151,732. After getting this value, find f of x3. f of x3 means the notation f3. f3 means what? Cos x3 minus x3 into e power x3. x3 is here. Substituting x3 value, the result is 0.21751,622. Okay, this is the first approximate root. Now coming to second iteration. Second iteration, what is that? Calculate h3. h3 is nothing but x3 minus x2. You know x3 and x2, subtract those two, 55, I'm getting 48268. Next one, h2 value, that is x2 minus x1, that's value is 1. Next one, lambda 3 expression. Lambda 3 is what? h3 by h2 minus 0.5584828, lambda 3 value. Next one, delta 3 value. Delta 3 value is what? 1 plus lambda 3. This value is 0.44151,732. Okay, then c2 and c3 and g3. g3 is equal to lambda 3 square f1 minus delta 3 square f2 plus lambda 3 plus delta 3 of f3. Substituting every value, the result is 0.71103,102. and c3 value, formula lambda 3 into lambda 3 f1 delta 3 f2 plus f3, and value is minus 0.34662184. Okay, and what is g3 value? Positive. Now you write, since g3 equal to 0.71103,102 is positive, consider positive sign in the denominator of Muller's formula. That is, what is Muller's formula for what? For x4. Okay, and what is lambda 4? Before going to find x4, find lambda 4 value. The formula is minus 2 delta 3 f3 by g3 plus or minus, now consider plus because g3 is positive, g3 square minus 4 delta 3 f3 c3. Why we are considering positive value? The denominator of this Muller's formula gives minimum value for lambda 3. When denominator is more, obviously lambda 4 is very less. So this is equal to minus 0.19207436 by 1.51023027. So this value is minus 0.1271817. Okay, then what is the next formula? Then the next root is x4. x4 equal to, what is the formula? x3 plus lambda 4 into x3 minus x2, and this is 0.51254636. This is second iteration value. Question is perform 2 iterations, therefore this is the result. Now take 2 assignment problems on Muller method. Muller method. First, okay, question is perform 2 iterations with the Muller method. 2 iterations with the Muller method for the following equations. First one is x cube minus 1 by 2 equal to 0 with initial approximations x0 0, x1 1, x2 1 by 2. Second question, log x to the base 10 minus x plus 3 equal to 0 with initial approximations x0 equal to 1 by 4, x1 equal to 1 by 2, x2 equal to 1. These two are the problems, assignment problems. Perform only 2 iterations. Now next method is Chebyshev method. Chebyshev method. After Muller's method, the next method is Chebyshev method. Here consider, see the method, consider the second degree polynomial. Consider the second degree polynomial f of x equal to a naught x square plus a1x plus a2. Second degree polynomial equation that is equal to 0, where what is the condition? A naught must be not equal to 0. Here we have to determine the arbitrary constants. We'll write like this: a naught, a1, a2. Okay. Now in the previous Muller's method, we have taken some determinant approximation. That means we consider three initial approximations: xk minus 2, xk, and xk minus 1, and express this equation at xk minus 2, xk minus 1, and xk. Then we form the determinant equal to 0. From that we are getting Muller's thing. Now in Chebyshev method, to get these constants, use the following conditions. Here we are using derivative conditions. Okay, use the following conditions. What are the conditions? First one, at x equal to xk, take this as equation 1. At x equal to xk, 1 implies, this is simply fk a naught xk square plus a1 xk plus a2. This is the first fk only, I'm not taking equal to 0. Expression of f of x at x equal to xk. Now differentiating one, what is f dash of x? Okay, let me write here. Now f dash of x is what? 2 a naught x plus a1. Then f dash of x value at xk. f dash x value at a xk. So that short notation is fk dash equal to what I am getting, 2a0 xk plus a1. Now one more derivative, f double dash. Since three unknowns are there, we required three conditions, so I am taking the function and first derivative and the second derivative. What is this? Is simply 2a0. Then at xk, what is this double derivative? Fk double dash equal to simply 2a0 value. Okay, from this last value, what I am getting, a0 equal to 1 by 2 fk double dash. This is a0 value. This is a0 value. Then what about this equation? Then this equation implies fk dash equal to 2a0 value. I know what is that value, fk double dash into xk plus a1. From this, what I am getting, a1 value as fk dash minus fk double dash into xk. This is a1 value. This is a1 value. Next one, substitute a0 a1. Let me take, this is 2 and this is 3 and this is 4. Okay, a0 a1 in equation 2. Then a0 is known, a1 is known. Substituting these values, you will get a2 value. Therefore, what is 2 implies? Then fk is equal to fk double dash by 2 xk square, right, plus fk dash minus fk double dash xk. This is a1 value, multi a1 xk, a1 value substituted a2. From this, what is a2 value? After simplification, I am getting fk minus fk dash xk plus 1 by 2 fk double dash xk square. This is a2 value. Now what we have to do, substitute a0 a1 a2 in equation 1. Then 1 implies, what is 1 actually? a0 x square a1x plus a2 equal to 0. If I substitute in this expression, what is the first one? a0 value. a0 value is what? 1 by 2 fk double dash x square plus a1 value. What is a1 value? fk dash minus fk double dash xk into x. Now a2 value, fk minus fk dash xk plus 1 by 2 fk double dash xk square equal to 0, right? Now from this, what is let me write first fk first. Next, first derivative term common. Where is the first derivative term? This is the first derivative and this is the first derivative. If I take common first derivative, then what are the coefficients here? 1x is there, this into this x is there, and minus xk. It is multiplied by what? fk dash. Next terms are what? This term, double dash terms, this term and this term. Okay, this one. Okay, in this all these, what is the common? I can take 1 by 2 fk double dash common. Then what is the first one? X square minus, here 2 is not there, therefore I have to multiply with 2 xk x, and here xk square equal to 0. So what I am getting? fk plus x minus xk into fk dash plus 1 by 2. What I can write this bracket as? X minus xk whole square fk double dash equal to 0. This is equation 5. Okay, this is equation 5. It is clearly nothing but it is what is a model? Like Taylor series formula, fk x minus h into f dash k plus x minus xk by factorial 2 into factorial 2 into y double dash, like that. So Taylor series expansion up to second degree, isn't it right? Okay, and neglect higher derivatives. And this equation 5 is quadratic equation, right? This equation 5 is quadratic equation, and can be solved quadratic equation, and it can be solved very easily, quadratic equation. And only one of the two roots, there are two roots for the quadratic equation, only one of the two roots converges, to the correct root, since it is quadratic equation, I can apply the formula to solve to get the roots, and among the two roots only one root converges to the exact root. In order to get the next approximate root, see this equation, rewrite equation 5, as xk plus 1 minus xk. You write like this better. In the equation 5, from the equation 5, one can write the second term x minus xk fk dash equal to minus fk, take the remaining terms onto the right side, minus 1 by 2 x minus xk whole square fk double dash, correct? Now replace, to get next approximate root, replace x by xk plus 1 to get next approximate root. Replace x by approximate root. Then what is the equation becomes, why we are replacing here, only x gives the root value, so replace x by xk plus 1 to get the next root. Then what we have, already I have written, then xk plus 1, then xk plus 1 minus xk equal to, take this fk dash also onto the right side, so minus fk by fk dash minus 1 by 2, this is also xk plus 1 minus xk whole square fk double dash by fk dash, take this as equation 6. Okay, now the logic is, now this is important, this is xk plus 1, okay, equal to xk minus fk by fk dash, right, by 1 by 2 xk plus 1 minus xk whole square fk double dash by fk dash. What I am doing, just I am taking this xk onto right side, that's it. Now the most important point is here, replace or substitute xk plus 1 minus xk plus 1 minus xk by NRM formula, Newton-Raphson method. That is, what is the formula? Xk plus 1 equal to xk minus f of xk by f dash xk, right? This is the formula. This implies, what is xk plus 1 minus xk value? This is minus fk by fk dash. Now replace this one here. Okay, then what I am getting, then xk plus 1 is equal to xk minus, second term is fk by fk dash minus 1 by 2, we are replacing with the Newton-Raphson formula, so whole square is there, so fk square by fk square into k, so this is cube, fk dash cube into fk double dash. This is called Chebyshev formula. is called Chebyshev method. Is called Chebyshev method. Okay, what is that? We are using Newton-Raphson method formula to replace xk plus 1 minus xk, isn't it? Right? This is called Chebyshev method. Now, one can replace just one point. One can replace xk plus 1 minus xk by secant method, by secant or regular falsy method. But the method is not known as Chebyshev method. If I replace by Newton-Raphson method also method only, then the formula is known as Chebyshev method. Is that clear? So remember this point. And in Chebyshev method, how many functions are evaluated? In Chebyshev method, f dash is required, f double dash is required, are required at what? X equal to xk. That is, what is the meaning of this? There are three function evaluations. In this method. Three function evaluations means f dash and f double dash. Three function evaluations are required in this method. This is about Chebyshev method. See, in Newton-Raphson method, just the point is came here, so I will tell here. In NRM, in Newton-Raphson method, what is xk plus 1 equal to xk minus fk by fk dash, right? Here two function evaluations are required. Here two function evaluations, f and f dash are required. Next one, in secant method, or RFM, regular falsy method, what is the formula? Xk plus 1 is equal to xk minus 1. One can write like this: xk minus 1 fk fk minus 1 whole by fk minus 1. Means what functions are required here? fk minus 1 are required, are needed, but two values are needed, but one function evaluations, only one function, that is f, is required. One function f, you write like this: one function evaluation, that is f is required. See, fk minus 1 means not two function evaluations, only one function f of x is evaluated at 2 points, so only one function evaluation is required. Okay, this is the function evaluation. So among all these methods, which is the costliest method? Chebyshev method is costliest required, because three function evaluations are required. Next costly method is Newton-Raphson method, because two function evaluations are required. And cheap methods are bisection method and secant or regular falsy method.